What we have here is a simple series circuit consisting of a battery with 9 volts, an ideal battery in which it doesn't have any internal resistance of 0 ohms. We also have a resistor of 10 ohms. Let me get rid of the electrons so you can see it. So this is how it looks in a realistic sense, where you have the resistor of 10 ohms and a battery that are connected together. These are just wires here and here. So this forms a circuit. So we have a 9 volts across this 10 ohm resistor. Now we'll show the electrons that it takes a closed circuit to form a working circuit. So here's our voltmeter. Show the electrons real quick. Flowing. Okay? So when you measure voltage, it takes 2 points. So here's 1 point, the positive side, and our black probe right here is our reference. And you can see here it's 9 volts going through this 10 ohm resistor. Now if I change the resistor to 1 ohm, we should expect a faster and larger current. And that's shown here, but we still have 9 volts across it, but except it's a smaller resistance. Now if I hook up a non-contact ammeter, we could see it's 9 amps. Because using Ohm's law, V equals IR, 9 amps times 1 ohm is equal to 9 volts. Now let me change the resistance to 10 ohms. You can see the electrons slow down, and this time our current is decreased by 10, or 0.9 amps. Let me slow it down even more with a larger resistance of 100 ohms. And we can see the current changed to 0.09. But 0.09 times 100 ohms is 9 volts across this resistor. So it takes 2 points and a cross variable to measure voltage, and it takes 1 point to measure current. This is a non-ideal non-contact ammeter, and I just put it over the wires. So here we also get 0.9 ohms. We can say that this resistor right here and this battery are connected basically in series, or you can consider it in parallel since there are 2 points in common. What I could do next is connect another resistor that has the same value, and recall the value of this resistor is 100 ohms. So what I'll do is get rid of this wire and add another resistor. Then put another wire connecting these and this. Okay. So connecting two resistors in parallel. Now I'm going to change the value of this resistance to also 100 ohms. And what it should be is half of the voltage. Since these are equal resistors, we expect it to be in half, and we'll go through the analysis in showing that. But right here we know it's 9 volts, but the voltage across this resistor now and this is the same potential, is 4.5, or half the voltage of that supplied. And we can see the current here is also smaller. What we could do is change the resistance so we can see the current here. Change resistance to 10 ohms, and we'll change this as also to 10 ohms. And we see it's half the voltage again, since these two resistors are equal. Again, this is what we call Kirchoff voltage law. It's an energy conservation. So the battery supplies the energy, and these two resistors dissipates energy supplied by the battery. And you can see here, since we have 9 volts supplied and a resistance of 20 ohms, 9 volts divided by 20 ohms is 0.45 amps. Now the current is the same in here and in here and in here. So this